friends, welcome to a new video on my channel. So this is episode 2 of my life learn live Raspberry Pi. So in this series I basically do everything live in front of you guys and teach you everything what I know about Raspberry Pi, so that a noob can simply write some code or simply do their DIY projects by himself or herself. Okay, so I am not going to teach everything very fast. I basically steps to step I explain everything, and though the video length is very though the videos are very lengthy, but I try to cover a simple thing. Okay, in the program I even put a single dot, but you have to know what the purpose of the single dot. Okay, so let me figure out what are the agenda of today's video. So basically there is two program, and after writing two different program we basically combine them and make a single program. Okay, so what are those two programs? So first of all, there is a blink program, which is a very famous program for the Arduino, and we make a similar program in our Raspberry Pi or over a Raspberry Pi, and for that we are using the Python language to code our script in the Raspberry Pi. So in the previous video I very depth I explained what are the different thing you have to know before you start working on a Raspberry Pi, or how you can set up your Raspberry Pi. So if you missed those videos, please go back and watch them, and after that come to this video and let's write our first program in Raspberry Pi. Okay, so first of all we need some LEDs, something like these LEDs, small LEDs. Okay, these are 3-volt LEDs, and to regulate the power we simply use some resistor. Okay, and we also need some jumper cable for our connection purposes and a breadboard. Okay, so basically to prototype this kind of things we have to we need a breadboard. So after you have those things handy with you, and obviously a Raspberry Pi which is running a Raspberry and Booster OS. Okay, so at the time I am shooting this video, the latest operating system is Booster, and which I am using right now. Okay, so basically the circuit diagram is something like that. This is a Raspberry Pi 3 Model B version, and I basically use these 3 pins, only those 3 pins, for explaining two things: how we can use the digital output of a Raspberry Pi through those GPIO pins, how we can use the digital input of a Raspberry Pi through those GPIO pins. Basically the GPIO pins are the major factor why the hobbyists, the hackers, the embedded system developers are using the Raspberry Pi over other boards, because it has 40 GPIO pins and we can use them by using the simple Python programming. Okay, so the connection is something like that. For the first program I basically pull the ground, and to know more about the GPIO pin connections we have a simple code for our Raspberry Pi, and that is pinout. Okay, so as soon as you press the enter after pinout, you see that this is the pin structure of a Raspberry Pi, and if I simply drag it little bit, 1 second, you can see here is a whole diagram which I see the GPIO pins are using, and what is the structure like that. So here the desktop size is small, that's why here is a little problem. So this is a pin structure of a Raspberry Pi Model B, and this is the pin. So I am using this pin, the common ground. Okay, so the 6th pin is a ground, so I use this pin as a common ground for our this project, and this is a common ground of our to provide the ground to our LED, and in the positive terminal I simply use a jumper cable and connect it to the pin 8. Okay, so basically the numbering goes like that: 1 2 3 4 5 6 7 8. So the 8th pin is connected to the positive terminal of our LED, and the ground pin is directly connected to the ground of the Raspberry Pi, which is the pin number 6. And after that we are ready with our circuit. Okay, after that we simply go to the Python ideally, which is the Python IDE for Raspberry Pi users. So simply here we are going to the file, and there is we create a new file. And here, instead of creating a new file, I simply open up previously written file. Basically, before this live session I shoot a whole live video of this program, but unfortunately that is deleted. I don't know how, but unfortunately that happens. So basically I explain the lines which I am written in this program. Here the first line is GPIO, import Raspberry Pi GPIO as GPIO. So basically we are importing a library which is called Raspberry Pi.gpio. So what the library contains? The library contains all the definition, how the processor is going to use the GPIO pins, how the processor can toggle the GPIO pin as an output or an input, and something like that, how we change the value present in the GPIO pins, and everything, each and everything about Raspberry Pi's GPIO pins. And we give a alias name so that it is easy for us to recall the name or recall the library multiple time in our program. So after that we basically set up the pin mode of our Raspberry Pi. So what is a pin mode? The pin mode is basically something which tells the Raspberry Pi, or something tells the Raspberry Pi compiler which pin is what. Okay, so basically there is two basic pin format, and that is a board and BCM. And in this blog, so basically visit my blog dnyindia.com/blog, and here you can find a blog which says Raspberry Pi 4 pin out. The 4 and 3 Raspberry Pi 3 pin out and the 4 pin out are basically the same. So 4 and 3 pin out for BCM versus board format. So I simply explain what are those things and why we are using them, and something like that, each and everything about those structures. So continue with the video. So basically here I use the board format to map the pins of the Raspberry Pi, and after that I basically set up a pin for output as the output. So basically I tell the compiler that I am going to use the pin 8 as the output pin. Okay, so you can see in the circuit diagram, here I am using the pin 8 as the output pin. So the same thing I am telling here or defining here as an output pin. So how you can use the GPIO, any of the GPIO pin as an output, is something like that. GPIO.setup 8, GPIO output inside the parenthesis. So basically we pass this value to this function, and the function is stored in GPIO, which is the Raspberry Pi.gpio. Okay, so after that I simply create a infinite while loop. Basically I am trying to replicate the blinking format, and in that format I basically use a delay. Okay, so basically in Arduino programming, how we can provide the delay? Simply we call a function called delay and pass a value which is in form of millisecond, but in Raspberry Pi we are using the GPIO. Okay, so in this GPIO pin format we basically use the value, the function which is called the time. Okay, this is also a library which contains a function called sleep. Okay, so this sleep function is basically replicate the same fundamental thing like a delay. Okay, so it provides a delay to our program. So to provide after we initialize the while loop, or after starting the while loop, which is an infinite loop, we basically pass a function. So what the function does, this function basically outputs the value. Okay, outputs some voltage. Okay, what the voltage, the true or the 1 is representing the plus 5 volt, which is the positive threshold value, and the false represent the negative threshold value. Okay, so GPIO dot output, here I am giving the false, means I basically toggle the pin voltage between plus 5 volt, let me comment out, plus 5 volt and 0 volt. Okay, so basically we toggle the pins voltage between plus 5 volt and 0 volt, and this toggling is repeated n number of time inside the while loop, and to provide a delay between them, we basically called a function called time.slip, and we pass 1. So here one thing is very clearly visible, that I am not going to put a value like 1000 or 100, because why? Because in the sleep function, the value which we pass is a second value. Okay, this is not a millisecond, this is a second. Okay, that's why I provide 1, which what it does, it basically stop the whole process for 1 second, and after that it start or resumes the execution of the program. And so let me run the program, and as soon as I run the program, you can see the LED is start blinking. Okay, you can see that the LED start blinking. So the first program is properly working and it is running. So simply move to the next program. Okay, so what is the next program? In the next program, I basically use the fundamental of a input, digital input. Okay, so basically I am using a push button, which is the most easiest way to explain how a input function is working in a Raspberry Pi. So basically I put a push button here inside the breadboard and connect one of its terminal to the ground. Okay, so it is the common ground. I provide the common ground to one of the terminal, and from the other terminal I simply give or connect it with the 10th pin. Okay, so what is the 10th pin? So you can see I am using this 10th pin here for the input, to take the input inside a Raspberry Pi, and this is the common ground, you know already. So basically let me open that file to open in. All these files are present in my blog, so do check that out. And if you have any questions or query about any topic over Raspberry Pi, feel free to ask me over any of the platforms, like in my blog or in the comment section below. You can simply reach out me there. So here I am not going to explain these two lines and not also this line, but from this line the code is changed a little bit. Okay, so let me drag that side by side so that it is easier for you to understand what is going here. So these three lines are the same. Okay, these three lines are the same, but the main change happened here. So you can see that here I set up the 10th pin as the input pin, and to do so I am using simply GPIO.in. Okay, I pass that value to the function setup, which makes the pin as the input, and after that here is a long string, and what it does, it makes the input pin as a pull up. Okay, so if you don't know about what is a pull up and pull down, go and search what is pull up and pull down basically, and also see what are the advantage and disadvantage of those things over a normal GPIO input. Okay, so go and check that out. So basically what it does, it makes the pin as pull up. Okay, it makes attached a virtual pull up resistor to the Raspberry Pi. So what is the advantage of that? The wiring diagram is very simple, so you can simply use two wire to wire whole thing up, and there is no need of any resistor there. Okay, So after telling the program or the compiler that this is I going to use this pin as the input pull up, we simply create a while loop, and this is also a while true, because this is also an infinite while loop. And in this while loop, what we do, in this while loop we simply read the value of the pin. Okay, so what value is present on that GPIO pin, and simply store that in a variable. Okay, so what that value is, the function is GPIO.input, and simply we pass the pin number to here, and after that we stored the value which is written from that function to a variable. The inp is a variable which stores the value, and simply we put a sleep or a delay so that the serial monitor not flooded with the values, and after that we simply print the value. Or and as soon as I run the function, you can see that there is a one value is popping up randomly, and as soon as I press this the button, as soon as I press the button, the value 1 is changed to value 0. Okay, so we simply use the push button and explain how the input concept is working. So let me revise whole thing. Okay, so simply in this program we basically use a push button to give a input to the Raspberry Pi, which says the state of the Raspberry Pi's pin. Okay, so here the value 1 is given to while it is positive 5, and as soon as the pin is shorted with the ground, the value is pulled down to 0. Okay, and we can use that value to do anything. Okay, so simply let me bring those two code in a simple file. So for that I am creating a new file, and inside this file I basically combine the two code which I previously explained. And what the final code does, we basically want to replicate a situation in where the LED is turned off when the button is not pressed, and as soon as the button is pressed, the LED is glowing. Okay, so the simple concept, but it teaches you how you can use the input function of a Raspberry Pi pin and use it in any DIY project. Okay, so let me put two things. Okay, here in the first line I basically, these three lines are the same, and in the fourth line I basically add the GPIO setup, and here I basically tell the compiler that the pin 8 is used as output pin, and pin in the next line I simply tell the compiler that pin 10 is used as the input pin, and the input pin is the input pull up. Okay, so in the while loop what we do, simply copy this, and here I am using if function to check the state. If so, first of all I simply use, let me simplify the code. Okay, I can use the whole checking thing in a single line, but I don't do that because it matter how you learn the things easily, not for me how I can simply use the how I can teach you the in an express time. Okay, I am not going to teach you in a very fast way. I am simply use the simplest way to teach you, and that is by explaining each and everything. Okay, so if int, not inp, so int equal 0, so I need that while the int value or the input value is 0, we simply turn on the LED. I simply turn on the LED and remove this line because we don't need any delay here. And as soon as the value is going low, I need to switch off the LED. Okay, so here I put this, and after that I simply bring this thing here, okay, and remove the time. So this is a very easy and simple code, and what it does, it basically read the value from the button, and if the button is pressed, then and only then the LED is glowed, and as soon as we remove our finger or we unpress the button, the LED goes low. So let me simply run the code. First simply save the code. Okay, so I did something wrong. Okay, the variable name is INP, not INT. So let me run again. Okay, so there is no error, a single error is here, and you can see that the code is working properly. As soon as I put my finger here, the LED is glowing, and as soon as I remove my finger from the switch, the LED is turned off. Okay, the LED value is pulling down to 0 volt. So you can see how easy to program the Raspberry Pi using the Python, and how easy to use those input value and input or output tasks in a Raspberry Pi using Raspberry Pi's GPIO library. Okay, so I think that's enough for this video. Though the video is bit lengthy, but let me put some more content here. Basically, there is a safety advice using this in the Raspberry Pi field. I basically fried my own Raspberry Pi 3 Model B, and the main problem in the Raspberry Pi Model 3B is that if you short the plus 5 volt and the plus 3.3 volt accidentally in a Raspberry Pi for any millisecond value, then your Raspberry Pi become a dead, a piece of, sorry, I don't spell that word. The Raspberry Pi simply dies, and it don't boot up, and it does nothing. Okay, so simply try to avoid that situation. I simply waste my 3000 rupees, near about 35 US dollars, by doing this simple mistake. I simply put those connections naked, and accidentally those connections are touched each other, and my Raspberry Pi dies. This is the third Raspberry Pi which I have. So in the next video there is a sensor I using the DHT22 sensor in the next video, and I am simply make a weather station using Raspberry Pi, and I did everything in a live video. So it may be lots of error, it may be lots of problem, but I am assuring you at the end of the video you learn how you can properly use the DHT22 like today. Okay, so good night guys, have a nice day and enjoy and do whatever you want. So goodbye.